It's the slope of line N less than the slope of line P. Okay, so oops. So they intersect at point 5, 1. So they intersect there. But I mean, they could really be anything on there, you know, either of those could be inter P. That's not sufficient on its own right away. Number 2, the y-intercept of line N is greater than the y-intercept of line P. Okay, so like line P could go like that. The y-intercept of N is greater, but I mean, it could still be a line going like that, or it could be a line going like that, in which case, this case, the slope is less. In this case, the slope is greater. You just kind of visualize it. These are possible values of N. So that's not sufficient on its own. And then if I put it together, I know they intersect at this one point, and the y-intercept of N is greater. So again, ask yourself, what if they're positively sloped lines? What if they're negatively sloped lines? So if they're positively sloped lines, they're fixed to this point, and N's y-intercept has to be greater than P's. So in that case, P has a greater slope because the y-intercept starts down lower. In this case, P is greater than N. Now, what if they're negatively sloped lines? Starting there, they have 5, 1. They have to intercept there or intersect there, and then the y-intercept of line N still has to be greater. So N is like this, and P is like this. Well, the trick here is that even though P's or even though N's like is steeper, when they're negatively sloped lines, it's actually the less steep one that has the greater slope, because slope is a measure just like any other number. You know, a slope of, let's say that's -3 and that's -1. -1 is greater than 3. So even in this case, slope of P is greater than the slope of N because it's less negative. So that's sufficient together.